This question illustrates very clearly the difference between displacement and distance when you are working with integrals. It's really important that you have that distinction very clear in your head so that you don't make errors through misunderstanding what the questions are asking. Okay? A particle starting from rest accelerates according to the rule A equals 3t multiplied by 2 minus t. Determine a relationship between the velocity of the particle and the time. All right, now we need to remember that we need to acknowledge the relationship, and we know that velocity is our integral of our acceleration with respect to time. So that means we have an integral of 3t to take t, and I'm just going to expand that, and I'm going to integrate. Okay, and that gives me 3t squared minus t cubed plus c. Now, it's told me that the particle starts from rest. So I know when t equals 0, v equals 0. So I know that v equals, 3 times 0 squared minus 0 cubed plus c. Therefore, I know that c equals 0. So my equation for my velocity is just 3t squared minus t cubed. Okay, now it says determine the displacement of the particle after 4 seconds. Now, it's important to know displacement is your definite integral. Definite integral. Don't have to sketch, so no sketch, no worrying about signs, because displacement is where you end up. It's not the distance traveled, it's how far away from the origin you are, so you don't have to worry about positive and negative integrals. Okay, we still have to say displacement, or x, let's call it x. X is our integral of velocity with respect to time. So we have 3t squared minus t cubed dt, and I'm going to integrate that. Now it said after 4 seconds, so that means I'm integrating from 0 to 4, and that's a definite integral. So I have 3t cubed over 3 minus t to the 4 over 4 from 0 to 4, and let's tidy that up before I do anything with it. T to 4 over 4, 0 to 4. So I have 4 to the power of 3 minus t4, 4 to the 4 over 4 minus 0, and when I work through that, I get 4 cubed minus 4 cubed. Oh my goodness, my displacement is 0. What does that mean? It means that this thing is back where it started after 4 seconds. Okay? It has returned to the origin after 4 seconds. That's why I have a 0 displacement. Alright, now it says sketch the graph of velocity versus time for the first 4 seconds of the motion. Now, this velocity curve, it's a cubic. We're only interested in part of it. The easiest way is probably to just draw a little table of values with a few significant points, and that'll give you a good idea. So we're looking at, T and V. And let's take it from 0 to 4, okay? So we have t, and we have v, and we're going from 0, 1, 2, 3, and 4. And our equation is 3t squared minus t cubed. Now, if this is take active, you stick it in your calculator, you say using graphics calculator, and you copy it, okay? But basically here I have when time is 1 is 2, 4, 0, and negative 16. And that gives me sufficient points you might want to extend this. Wasn't long enough for me. Okay, so we have 1, 2, 3, 4, 4, 8. Okay, and I went, it was 2, it was 4, 3 it was 0, and 4 was negative 16. Okay, so that's what my function looks like for my first 4 seconds. Alright, and the reason they wanted us to sketch it is because now we have to calculate the distance traveled. Now the distance is the signed area. Okay, we can't ignore the signs. We have to know what our graph looks like. Well, that was a bit squiffy for the 4. And we need to be able to work through with our signed area. Okay, so I'm going to draw a line there and just fix my graph. Okay, so what we have is we have area 1, which is a positive area, and area 2, which is a negative area. All right. So our displacement, x, is the area under the curve, which is equal to area 1 plus negative area 2. Okay, and you might want to make a little note for yourself. Distance is going to be the signed integral, and you need a graph. Alright, so that means I have that x is going to be the integral from 0 to 3 of my velocity minus my integral from 3 to 4 of my velocity. Okay, so I have my integral from 0 to 3 of 3t squared minus t cubed dt minus the integral from 3 to 4 of 3t squared minus t cubed dt, and I have t cubed minus t to the 4 over 4 from 0 to 3 minus t cubed minus t to the 4 over 4 from 3 to 4. And I'm just going to go on over here because I'm running out of space. And that gives me, okay, let's put that in. We have 27 minus 81 on 4 minus 0 minus 4 cubed, 64 minus 256 on 4 minus 27 minus 81 on 4, and that gives me 27 minus 81 on 4 minus 64 minus 64, 27 plus 81 on 4, and that gives me 27 minus 81 on 4 plus 27 minus 81 on 4, and when I work that through I get 13.5 meters. Okay, so the total distance traveled in 4 seconds is 13.5 meters, even though my displacement is 0.